Okay, in this example, we're going to talk about focal length of a parabola and how that relates to its equation. So what is a focal length? So focal length is defined as the absolute value of c. All right, it in words is the distance between the focus and the vertex. And it's measured along the axis of symmetry. Okay, so just a reminder that parabolas have an axis of symmetry. If we look at this parabola down here, there's a line that cuts it in half. That's a symmetrical line where the left side would map onto or mirror the right side. So that's your axis of symmetry. So if we look in the picture, here's our vertex, here's the focus. The focal length is the distance between those. And because it's a distance measurement, that's why we use those absolute value bars. Okay, so how does the distance between the focus and vertex affect the shape of a parabola? So it's all about that c value. If your c value is greater than 0, that means that your parabola opens up or to the right. So a positive c value tells you that your parabola opens up or to the right. If your c value is less than 0, so a negative c value, your parabola opens down or to the left. All right. How does the focal length relate to the equation of a vertical parabola? So this is what we call a vertical parabola. It opens up and down. The axis of symmetry is a vertical line. All right, let's do some math again. So we know any point on the parabola is going to be equidistant from the focus and the point on the directrix. So we know that PF is going to be equal to PQ. And this is point Q and this is point F at the focus. So let's just see what happens when we find those distances. So the distance from P to F, we're going to subtract the x's, x minus 0 squared, plus subtract the y's, y minus c squared. That's equal to the distance from P to Q. Let's subtract the x's. We've got x minus x squared plus y minus a negative c turns into plus c squared. All right, to simplify this, let's square both sides, get rid of your square roots. As we rewrite this, we'll do some simplifying. X minus 0 is just an x squared, plus we have a y minus c squared equals, we like that, x minus x is just 0 squared, so that simplifies away, but we would carry down, we have a y plus c squared. Okay, so let's square those binomials. On the left, we'll have x squared plus a y minus c times a y minus c is y squared minus 2cy plus c squared equals a y plus c squared is y squared plus 2cy plus c squared. All right, do we have anything that we can cancel from both sides of our equation? I see a positive y squared canceling with a positive y squared, a positive c squared canceling with a positive c squared. Let's carry down what we have. We have x squared minus 2cy equals 2cy. Let's go ahead and get those cy terms to the same side. So we have x squared equals 4cy. We will divide this one by y, or no, we'll solve for y. dividing by 4c. So our equation is y equals, that divided by 4c, we're going to write that as 1 over 4c times x squared. So there's our equation that is relating the focal length c to the vertical parabola. All right, our next question, you guys are going to like this one because this one does not involve all that algebra. We're just going to work on understanding what all this is still. What does it look like? How does it all fit together? A parabola has a focus of 4, 0 and a directrix at x equals -4. What is the vertex of the parabola? So we often will start by sketching out these graphs. We can plot the things that they gave us. They said the focus is 4, 0, so 1, 2, 3, 4. The focus, which is on the inside of your parabola, is at 4, 0, and the directrix is at x equals -4. So that's going to be a vertical line, 1, 2, 3, 4, going through the x-axis at -4. So what we know about these parabolas is the vertex is going to be halfway in between these. These are the same distance away from the vertex. It's that focal distance that we talked about. So the vertex has to be right there at 0, 0. This parabola is going to open toward the focus so that the focus is in the middle of your parabola like that, or on the inside of it. And if we just check our focal distance, 1, 2, 3, 4 is 4 units, which means we have 4 units on the other side as well.